Hello, today we're going over section 4.3, adding and subtracting rational expressions. In this video, we'll talk about how to find the least common denominator, and we'll go over problem number 3 and problem number 4. How do you find the least common denominator? How is that different than finding the greatest common factor? Well, it's simply the difference between multiplying and dividing. When you find the least common denominator, it's like finding the least common multiple. It's the same, except denominator refers to that bottom part of the fraction, but you really are finding the least common multiple of the two terms or the two denominators or whatever. So the least common multiple is what you can multiply into. For example, 5 and 10. What can both of them be multiplied into? 10. If you list all the multiples, 5, 10, 15, 20, and the multiples of 10, 10, 20, 30, 40, what's the smallest number that appears in both lists? 10. It's the smallest or the least common multiple. So we're looking at things that we can multiply into. What about the greatest common factor? That talks about dividing. So between 5 and 10, what's the greatest common factor? What can they both be divided by? And the answer is 5. So be careful when you're thinking about how do I find the lowest common denominator? Think about things you can multiply into. That's one way to think about the difference between LCM and LCD. Now we're talking about finding the lowest common denominator when we have rational expressions that involve variables, letters, binomial terms. It's not just a number like we've done in the past. And so we have to think about the prime factorization of each piece. When I take all the primes to find the greatest common factor, I'm just taking the common primes from each. When I find the lowest common denominator or the least common multiple, I need one of each of the distinct primes. So notice I have 2 and 5 and x. And then in the second term, I have 3 and x plus 1. When you think about 10x squared and 15x times x plus 1, what can both terms multiply into? 10 and 15 can both multiply into 30. X and x squared can both multiply into x squared. So when you take the greatest common factor, you want the smallest exponent. When you take the least common multiple, you want the largest exponent when you're thinking about variables with exponents. Okay, what can they multiply into? X squared. And then x plus 1, you've got to multiply into it, so you need that in your LCD. Let's refresh how to find the least common denominator between 24 and 6. What can both be multiplied into? They can be multiplied into 24, so the LCD is 24. What if I thought about it the way using primes? What are the primes of 24? So 24 is 6 times 4. So we have 6, which is 2 times 3, and then 4, which is 2 times 2. And the primes of 6 is 2 times 3. Okay, so how do I find the lowest common denominator or the least common multiple? I need the most of any distinct factor. So this person gives me the most 2's, and they both give me the same amount of 3, so it doesn't matter if I take the 3 from here or the 3 from there. Then I see the LCD is 24. Again, looking at 10x squared and 15x, x plus 1, I need the most of any common factor. That's how I get 2, 5, 3, and x squared and x plus 1. Let's use that knowledge to try problem 3 and problem 4. Find the least common denominator of m squared minus 16 and m squared plus 8m plus 16. What should we do first? Factor. We notice this is the difference of squares, so m plus 4 times m minus 4. Those are the two factors. And then of the trinomial, we'll set up our template. We'll put m times m And we notice 16 is positive, so it's either both positive or both negatives to multiply to get 16, but the 8 is positive, so we know they're both positives. Two numbers that multiply to give you 16 and add to give you 8 would be 4 and 4. Now I consider my terms. I need what can everything be multiplied into, and the most of each distinct factor. Okay, so we have two m plus 4s here. We need both of them. And then we have an m minus 4. So what is the least common denominator? M minus 4 times m plus 4. And see, there's two of them. Then you could just put m plus 4 quantity squared. The most of each distinct factor. Or what can both terms multiply into? Let's try problem number 4. What is the common denominator for 2y plus 6 and y squared minus 9 and y? Okay, what can we do? Factor. So I can take out a 2 and I get y plus 3. Then I see that this is the difference of squares. So the second denominator would be y plus 3, y minus 3. And then for the third term, I have a y. Now I need the most of each distinct term. This one gives me a y plus 3, but so does he. So to find that common denominator, I see y plus 3, y minus 3. We already have one of those, so that's fine. I also need the y, and I also need the 2. You need each. What can they both be multiplied into? You need each distinct term, the most that anyone gives you. Okay, so now I put it together, 2y, y plus 3, y minus 3. It's fine to leave it in factored form. And in fact, when we start using this common denominator to add and subtract, it's nicer to have it in factored form. I hope that helped a little. See you again later.